So we're going to be talking about word problems involving geometry and distance. Two different types of word problems. I highly recommend that you watch the other video for word problems involving general quantities and length. I will be referring to that video in this video. So I recommend watching that one first and then this one. So, solving problems like geometry and distance. First of all, let's talk about geometry problems. There's a lot of different types of geometry problems. The one that we're going to be looking at in this video are problems involving perimeter. So, what is the idea behind perimeter? Well, let's say we have a rectangle here. Rectangle is made up of a width, let's go ahead and call the width W, and a length, let's call the length L. So the perimeter of any shape is always equal to the sum of the sides. The sum of the sides. Now, the sum of the sides in this case is going to be the width plus the length plus the length, since we see we have 4 different sides. Another way to simplify that is twice the width plus twice the length. So we're always going to use this relationship when dealing with a problem that involves perimeter. Especially if we have perimeter of a rectangle, then we know that we're going to use this relationship right here. Twice the width plus twice the length. This is a very useful formula. Another thing to keep in mind is that we are going to solve using the same method as general word problems. In other words, you can see the first video on word problems. So you're going to follow the method in the other video. The only difference is that the relationship that we're talking about is always going to be perimeter equals twice the width plus twice the length. Very important to keep that in mind. Okay, so let's do our first problem. So this is problem 1. John wants to fence his rectangular backyard. He calculates that he will need 220 feet of fencing and that the length is 6 feet more than the width. Find the dimensions of the fence. Okay, so let's remember the steps from the last section. We always start by letting x equal our variable. In this case, we might want to use a different letter. Let's figure out what the unknown is that we're talking about. We're talking about length and width. It says find the dimensions, so that's what we're looking for, the length and the width. Notice it says the length is 6 feet more than the width. So the last mentioned one is width, isn't it? So I'm going to go ahead and I'm going to let W be the width. Since it's the second mentioned one, that's what I'm going to let my width be. Now I don't use L for the length, right? We're not there yet. We're in a later chapter, in chapter 5, or when we talk about doing systems of equations. In that video, we are going to have more than one variable. In this video, though, we are doing problems using only one variable. So it says the length is 6 feet more than the width. That means that W plus 6 would be the length. Sometimes it helps to draw a picture. So here's my rectangle. We've got the width, but then we've also got W plus 6 here. Now, it says that we need 220 feet of fencing around this backyard. Well, that means that the perimeter is 220, because if you were to fence off this thing, you would go exactly around one time, wouldn't you? Therefore, the perimeter, as we always know, is twice the width plus twice the length. But let's fill stuff in. We know the perimeter is 220. The width is W. And the length is W plus 6. So this is how we set up a geometry problem. Let's go ahead and solve this. In this case, we have to distribute this too, don't we? So we get 220 equals 2W plus 2W plus 12. Combine our like terms, we get 4W plus 12 equals 220. Subtract 12 from both sides. We get 4W equals 208. Divide both sides by 4. We end up with W equals 52. So, if W is 52, then that means that W plus 6 is 52 plus 6, which is 58. So we're ready to answer the question. It says, what are the dimensions of the fence? The width would be 52 what? Let's look back. It says feet. The width is 52 feet, and the length is 58 feet. And that would be our answer. Okay, so in general, these problems aren't too bad. You just have to remember to define your variables. In this case, choose one of the variables and then let the other variable be represented by the first. And then you're going to draw a picture. That does help. So I think that this picture is useful. Finally, you write your equation down. 3 main steps. Those are the hardest steps of a word problem. Alright, so let's try a different type of word problem now. I want us to focus on problems involving distance. Now, in order to talk about distance problems, I want us to talk first about a key equation that you use in every single distance problem. Now, in general, we have 3 things that we're talking about in a distance problem. We have distance, we have rate, and we have time. There's a key formula that relates these 3 things. And the formula is distance equals rate times time. So distance equals rate times time. A lot of times people remember this by writing D equals RT. Whichever way you like to remember it, just make sure that you know that distance equals rate times time. Now we're going to see a common theme for this video and also for any video or any problem we ever solve that involves more than one piece of information here. Now think about it. We have 3 things that we care about, right? Distance, rate, and time. What if we actually have more than one thing that's moving? For example, what if we have 2 cars that are driving in opposite directions, or 2 people that are running at different rates? We would have distance, rate, and time for all of these different things, and they would all be different. That's a lot of pieces of information. For example, if there were 2 cars driving, they each had their own distance, rate, and time. That would be 6 different things you have to keep track of. A lot of things to write down. So, what's going to help you? For more than one moving object, we're going to use a table. And you're going to see a common theme here. The table is going to be really useful for many different types of word problems. Now, what do I mean by a table? Well, we have rate, we have time, and we have distance. We also have a couple of things here. We have object 1 and we have object 2. And we use this table to solve the problem. So what are the steps going to be for distance problems? Well, for any problem really that uses a table, step 1 is always going to be to define your variable. Step 2, fill in the first 2 columns of the table using the variable and nothing more. Step 3, don't forget that rate times time equals distance. And that's what's going to go into column 3. Okay, column 3 being this column right here. Step 4, and the hardest part of all possibly, is to write down an equation using a relationship. This is going to be tricky, so this is why we're going to do a couple of examples so that you can see the different types of problems that can come up. Step 5 is going to be to solve the equation. And step 6 is going to be to answer the question as before. Don't forget your units. Just want to remind you guys, units are very important. Okay, so let's try a couple of these distance problems. So distance problem number 1, or number 2, I guess, for this video. 2 planes leave St. Louis, one flying east and the other flying west. The westbound plane travels 100 miles per hour faster than the eastbound plane, and after 1.5 hours they are 750 miles apart. Find the speed of each plane. Alright, so we are going to start by defining our variable. So it says find the speed of each plane. So we're going to start by writing let x equal the speed of, well, we need to figure out which plane we're talking about. Let's see, it says the westbound plane travels 100 miles per hour faster than the eastbound plane. Since the eastbound plane is mentioned second, I'm going to let x equal the speed of the eastbound plane. So what would the speed of the westbound plane be? Well, it says it goes 100 miles per hour faster than the other one. That means it's got to be x plus 100. At this point, there's a lot of stuff going on, so it's going to be really much easier if we write down our table. So here's our table. We have rate here. We have time here. We have distance here. We have the eastbound plane. We have the west plane. Now let's start filling in the table. We know that x is the speed of the eastbound plane. x is the speed of the eastbound plane, and x plus 100 is the speed of the westbound plane. So there's our two speeds. Remember though, we need to fill out the second column too. Notice it says that after 1.5 hours, they're 750 miles apart. That means that they each traveled for 1.5 hours. So I'm going to put 1.5 here and 1.5 here. Now for distance, don't be tempted in writing 750 either here or here. That would be wrong, because that would be saying that they each traveled 750 miles per hour, and they didn't. It says that that's how far apart they are at the end. So we cannot use that information yet. So look over here. It says rate times time equals distance, and that's what goes in column 3. So I'm going to do rate times time. So x times 1.5 is 1.5x, and that's my distance. This one's going to be 1.5 times x plus 100. Now, this is the tricky part. So the eastbound plane, we've got one plane that went this way, and this plane went a distance of 1.5x. We've got another plane that went this way, a little bit further because the west one is the faster one. So let's say this one, we already know how far it went, 1.5 times x plus 100. So it says that they are, how far apart are they? Let's see, 750 miles apart. That means that this whole distance is 750. That means that the sum of the distances is 750. And that is the key to the problem. So I'm going to write this distance plus this distance is equal to 750. That's how far apart they are. So let's distribute. 1.5 times x is 1.5x. 1.5 times 100 is 150. Combine my like terms, we get 3x plus 150 equals 750. Subtract 150. We end up with 3x equals 600. Let me continue over here. Divide by 3, we get x equals 200. So that tells us the slower plane, right? The slower plane is 200, but it says the faster one is plus 100, so I'm going to do 200 plus 100 is 300. So let's go ahead and write down the answer. The eastbound plane goes 200 miles per hour, and the westbound plane goes 300 miles per hour. And that is my solution. Okay, so I don't want you guys to think that you always add the distances here. That is only this one example. To illustrate that, I'm going to do one more example. Okay? This is going to be problem 3. It says, Alex and Jenny are taking a cross-country road trip on their motorcycles. Jenny leaves a rest area first, traveling at 60 miles per hour, and Alex leaves 30 minutes later, traveling on the same highway at 70 miles per hour. How long will it take Alex to catch Jenny? This is a much more challenging problem. Let's go ahead and work this one out. Okay? So we need to figure out what to make our variable. First of all, it says, how long will it take Alex to catch Jenny? So I'm going to let t equal the amount of time. Now we need to figure out how long someone has been riding in order for them to be caught. So it says, how long will it take Alex to catch Jenny? But let me go ahead and read the problem. It says Alex leaves 30 minutes later than Jenny. Alex leaves 30 minutes later than Jenny. So why don't we let t equal the amount of time that Jenny rides? Before she is caught. Okay, so she's been going the amount of time t before she's caught. How about Alex? How much time does he go? Well, since it says that he leaves 30 minutes later, that means that his time is 30 minutes less, right? Whatever Jenny's time is, let's say hers is 3 hours, Alex has to be 2.5 hours. Okay? Because Alex leaves 30 minutes later. So that means I'm going to write t minus what? Do I write t minus 30? Here's the problem with that. 30 is in minutes. However, I need to have everything in hours because notice I see miles per hour here, miles per hour here. Everything has to be in hours. So 30 minutes is the same as half an hour. And so I have to use that for the rest of the problem. So, back to the problem. If Jenny goes t hours before she's caught, and that means Alex goes t minus 1/2. That's the amount of time Alex rides before he catches Jenny. Okay, so there are the two unknowns in the problem. So let me go ahead and start writing our table here. We have rate, we have time, we have distance. We have Alex, and we have Jenny. Now, it says Jenny goes t hours, so that's going to be her time. Alex goes t minus 1/2, so that's going to be his time. What about Alex's rate? Well, the problem says Alex goes 70 miles per hour, so that means this is going to be 70. The problem also says that Jenny goes 60 miles an hour, so that's going to go right here. Notice the problem doesn't mention the distance, but that's okay. Remember how we get distance anyway. We multiply rate times time to get distance. So this is going to be 70 times t minus 1/2. And this is going to be 60 times t. Now we need a relationship here. We can't just add them together like we did in the other problem. We have to be really careful and read very, very carefully. We know that this is when Alex catches Jenny. So Jenny's over here. Alex leaves 30 minutes later, but if he catches up to her, then haven't they gone the exact same distance? If someone runs away from you and then you catch up to them, doesn't that mean that you guys ran the same distance as soon as you catch up to them? In other words, those distances that we wrote down actually have to be equal. So this is the key to this problem. Notice that this is different than the last problem. Now, how do we solve this? Well, first we distribute. 70 times t is 70t. Minus 70 times 1/2 is 35. Equals 60t. I did that a little quickly, but hopefully you remember. If you do 70 times 1 over 2, you multiply them together, you will get 70 over 2, which is 35. Let's go ahead and solve this. We're going to subtract the 70t from both sides. We get negative 35 equals negative 10t. Divide both sides by negative 10. We get t equals 3. Did I do this wrong? Sorry, not 3. I'm not paying attention here. 35 divided by 10 is 3.5. 3.5. Right? 35 divided by 10. So 3.5. Before we write that down as the answer, though, is that what we were looking for? This is the amount of time Jenny rides before she's caught. But the problem says, how long will it take Alex to catch Jenny? Okay, that means we need to subtract a half from it. We're actually looking for this, the amount of time Alex goes before he catches Jenny. So 3.5 minus a half, or minus 0.5, is 3. So we're done with the problem. We just write down the answer. It takes Alex 3 hours to catch Jenny. 3 hours to catch Jenny. So the important lesson to learn here is that every distance problem is different at the very end. However, they all start out the same way. You always have this rate, time, distance table, and you always fill in the first two and then multiply them to get the third. You only get better at these with lots of practice. Okay, good luck on your word problems, and I'll see you guys next time.